The most powerful CW laser build
Aren't
I've
those
shown on this
lasers on the order
channel.
of milliwatts?
Now, in order to visualize this ridiculous
Hi, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry, from engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Today we're going to be looking at another crazy experiment by styropyro. This one involving converting a microwave into a laser oven. I mean, hey, they're both types of non-ionizing radiation, just one's has a bit of a different wavelength than the other, right? So they could both cook food just fine. Let's check it out.
Hey everybody! Today I want to give some love to everybody's favorite household appliance, the microwave oven. Now for most people, these are simply a way to just heat up food in a hurry, and for that they're pretty decent. But for people like me, microwaves are so much more than that. Microwaves are useful for a lot of cooler things than just cooking food.
Is that a light bulb?
In fact, my parents' microwave was probably my first platform for experimenting with electromagnetism. Unfortunately,
I'm sure they
that oven,
appreciated that, buddy.
mysteriously died not long after they got it. The nice thing is that microwaves don't even have to be working to be useful to me. Lethality aside, the transformer and capacitor inside are great for high voltage projects like Tesla coils. The glass tray and turntable motor can be used to make a simple laser show, and even the oven casing itself is useful as a disposable blast chamber. Now I've done a ton of projects using microwave parts on this channel, but today I actually want to focus on the oven itself. And since this is my channel, I think there's some room to make some upgrades on this wonderful appliance as well. So yeah, I hope you enjoyed this video. Oh yeah, before I go on, I should warn you that all the crazy stuff you're about to see was done completely for educational purposes. I mean, if you were to try any of this stuff at home, you'd probably die. So yeah, please don't try this at home. Alright, so what kind of stuff can you even do with a microwave? Well, the obvious use is cooking stuff, but this isn't super exciting by itself, and it's often slower than I'd like. And besides, you can do this with an ordinary oven as well. But this isn't some ordinary oven. This is a science oven. This bad boy cooks food with a huge electromagnetic field. I can use this field to check on the condition of my low-pressure gas tubes. Has this plasma globe taken on air since the last time I hit it with a Tesla coil?
Explode, isn't it?
A quick run in the microwave shows that it's still intact, but not for long.
Hey.
How about these cheap neon indicators I bought on eBay? Are they any good?
That's cool.
I'll take that as a yes.
Blue reminds me of the
Microwaves are great for
Cherenkov
chemistry
blow.
as well. In fact, regular old microwave ovens have been used in chemical synthesis for years in academic labs. Now when it comes to actually cooking food, there's still a lot left to be desired. I mean, it's been over 70 years since the first microwave ovens, and yet the new ones aren't any more powerful. What gives? It turns out, the people who make these things have been feeding us lies for years. So hear me out. What happens when you use the 50% setting for slow cooking? Any self-respecting person would expect the oven to simply run at half power, but check out that power draw. What actually happens is that the oven runs at full power for an amount of time, then turns off for a while before repeating the cycle. Sure, it averages out given enough time, but it's still dirty. Now,
I never knew that
one's not that big of a deal, but it does lead us to the lie
That's really cool. I'm glad he just went through the trouble of putting up a meter to it just to see what it actually does, but I guess I never really tested that, so you don't really think about that. I appreciate him exposing how it really works. That's great.
Disgusting. What happens when you use the 100% setting? Most people don't question this setting because it's all they've ever known, but let's take a look at what that looks like in slow-mo. See how they flash like that? Yeah, that's right. Even at the 100% setting, the bulbs are only on half the time, and this is because the oven is only producing microwaves half the time. What a scam!
That's another way to test it.
Anybody who watches my videos knows that half power just isn't going to cut it for me. I think it's time for some upgrades. Alright, so I've taken this thing apart to expose the circuitry inside. Now I gotta say it, poking around in a microwave is not for the inexperienced. When electronics hobbyists get killed by their projects, it's almost always because they're messing around with microwave parts like these. Anyway, here's the reason why the oven's only on half the time. So this magnetron here, which is actually the source of microwaves in the oven, is powered by feeding the output of this high voltage transformer into this halfway voltage doubler circuit. Now the very nature of the circuit means that the magnetron is only going to be powered on half of the AC cycle. Now if the transformers in these things weren't ran so
that makes sense because of the way the current alternates kind of in a sinusoidal pattern when you use AC power just by plugging it into the wall. That makes sense.
close to saturation, you could just throw in another capacitor and diode to make the full wave doubler and call it a day. But you can't, so that means I have to sacrifice another microwave
Could use
for
a
the
rectifier.
But before I do that, let's start with a quick control run, because this is a science video after all, sort of. I'm going to start by ripping this plastic covering off of the door. The metal grid will still stop microwaves from escaping, but now I'll be able to see inside with my thermal camera.
Cool.
I actually learned this thermal camera trick from the YouTuber styropyro. Well, he's not really a YouTuber. I've just known him from various nerdy online groups over the years. But
I haven't used one for this purpose, but I know a lot of plant operators and actually very specific types of technicians would use a thermal camera when looking to try to identify a hot spot in, say, a pipe, for instance. But this looks a lot more fun.
have some cool vids on YouTube regardless. So a cup of water heats by about 28 degrees Celsius in a minute, which also suggests about 40% efficiency. Now obviously, this isn't quite fast enough for my liking. I went ahead and unlocked full power mode here. I've added another transformer, as well as some more diodes and capacitors to make the full wave doubler circuit.
One thing about efficiency is nuclear power plants, or really anything that uses a steam cycle, 33-35% is a pretty solid number. So anything north of that, it's like that. Hey, that's pretty cool. You can always look to try to get it better, but I like it.
But wait, won't a microwave using double the power trip the breaker? Well, it's nothing a little bit of copper wire and duct tape can't fix.
Oh, wow.
I'm just kidding. We have appliance outlets for a reason.
Yeah, okay.
I was too lazy to use the original controls on the microwave, so now I'm using this huge variac to power it. Now the nice thing is this actually allows me to control the power, as opposed to just plugging that abomination directly into mains. A quick power up with neon bulbs shows that the oven is indeed working. Slow-mo video confirms that the oven is actually producing microwaves on the full cycle.
Cool.
Sure, there's some ripple, but at least it's on the entire time now. A benefit of the new setup is that it bypasses all of the safety mechanisms, which means the oven door doesn't even have to be closed for it to operate. This is super convenient for the times I need to irradiate large objects with kilowatts of microwaves. I was curious how a camera would react inside my Faraday cage with the open oven, so I stuck one of my old cameras in there with it. Amazingly, it actually survived this. Now I should note that doing an experiment like this without extensive shielding will lead to the FCC and local hams hunting you down, so don't do that. Let's go ahead and redo that water heating experiment with...
Not to mention just, the hazard of a bunch of thermal radiation everywhere. Yeah, it's called safety for a reason. Note that, again, we're talking thermal. This is not to be confused with ionizing radiation that you would see by decay of radioisotopes. But hey, it's a heat source. Mentioning the FCC, a lot of communications involving towers involve radio waves, and microwaves are somewhat close to them on the electromagnetic spectrum. So yeah, it's going to show up somewhere.
Power microwave. The original microwave drew a little under 1200 watts, so I'm going to dial the power to about 2400 watts this time. Over the course of a minute, the power draw actually increased to about 2800 watts, probably due to the toasty magnetron filament spitting off more electrons as it heated.
Yeah.
The full power microwave heated the water way faster this time, 63 degrees Celsius in 1 minute. Some rough calculations show that the efficiency was unchanged as well, giving about 40%
that makes
efficiency.
sense. I mean,
how about something a little more practical?
Same aspects of thermodynamics
An
in
apple
play.
is heated to deliciousness in half the time it normally takes. Talk about convenience. Now I know what you're thinking. What happens when I give this setup even more power? Let's find out by cooking this banana at 4 kilowatts. Okay, let's slowly crank up the power there. Yeah, seems good. Oh, come on. It clearly arced over in there, but I'm not even totally certain why. The extra power certainly plays a role, but I think the geometry of the banana may be a culprit as well. I'm thinking it acts as a lens and/or antenna that focuses microwaves to the tip, which causes dielectric breakdown.
That's interesting. Yeah, the shape of it.
Maybe laying the banana on its side will prevent this from happening. Well, here goes nothing. That doesn't sound very good. Maybe I can just give it more power and I'll heat the banana along with the plasma. Nope. The magnetron is definitely dead now. Wait,
For the record, with stuff involving nuclear reactors, the solution is never, I'll give it more power to see what happens. If anything, if something that you can't control or something is in an unknown condition, you do the exact opposite and safely shut down the reactor. That's one way you can safely control whatever is going on, no matter what. And said process takes a couple of seconds. In a modern nuclear reactor, anyway, you turn the reactor trip switch, all the control rods fall in. And note that even if you didn't control them and you lost power somehow, they would just fall in, safely shutting down the reactor immediately in a couple of seconds. Note that I'm saying modern ones. Chernobyl had a whole bunch of other problems, and one of them was it took a lot longer for the control rods to fall, on the order of 12 to 20 seconds, which is, just another horrible design associated with them.
is it on fire? Oh, come on. Pocket sand.
I mean, that pocket sand.
Unfortunately, this puny little magnetron just couldn't hack the extra power. Now, it's not like I can just throw in a bigger magnetron either. Well, not without shelling out thousands of dollars. So why not use a bunch of smaller magnetrons? Well, the issue with that is then you introduce a bunch of phase matching and even impedance matching issues.
Yep, so phase matching, any sort of generator, including, I guess you can, magnetrons, kind of the same sort of thing. It involves moving electricity. You have to keep them in phase. Like whenever we tested our emergency diesel generators at the nuclear power plant, you have to match it with the grid when paralleling it with the off-site source. Otherwise, you just could potentially damage the diesel. So, yeah, no sense breaking a bunch of magnetrons here by trying to get everything lined up appropriately.
Wait, what am I thinking? Why are we using this dinosaur technology when we could be using freaking lasers to
Yes,
cook food?
the lasers. That's what I'm here for.
There's a few reasons, really. It
Oh,
takes
I'm
a
sure.
relatively huge amount of energy to cook food due to water's high heat capacity. So a laser that could cook in a reasonable amount of time would have to be ridiculously powerful and dangerous. Luckily, ridiculously powerful lasers are what I do best. In fact, I already have on hand some of the scariest semiconductor modules on the planet. These are inner laser diode arrays. They may not look like
Those are
much,
cool looking.
but each one is capable of tens of thousands
Wow.
of times as much power as a laser pointer. It's honestly
I
hard
never
to
played
convey
around with
just how
lasers too
dangerous
much,
each
but
one of these can be.
I do think they're
and the
cool.
hilarious thing is that I'm going to need to run a bunch of them side by side at full power to pull off cooking with them. Judging by the scratched out part numbers and lack of documentation, I'm going to guess that I'm probably not supposed to have these. So how am I going to turn these things into a laser oven? Well, honestly, I'm not even sure yet. I'm just going to start smashing things together until something works.
Sure. Is that mayonnaise? What? Okay, someone in the comments tell me why mayonnaise makes lasers, because that I never would have guessed. Or is this just a joke? Making a coil. Important, do not remove. Nice touch. This is cool. Whoa, that's Aurora Borealis in the back. Bunch of big D batteries. Why?
Alright, so this
That was the most hilarious building montage I've seen. Just smack it, do it to the beat, sure. Can you imagine if we built nuclear power plants like that? I'd imagine if we did that, they'd probably done with Vogel Unit 4 over in Georgia by now. It'd be operating right next to Unit 3.
What the completed laser oven looks like. So I have my array of laser arrays here on top, and that's powered via this power supply that's fed through some drivers on the back. Now I also added this water cooling loop here, just because there's so much power going through this thing that I simply couldn't get away with just some passive cooling there.
Sure.
The new laser-equipped oven draws about 2 kilowatts at full power,
Whoa.
and about 700 watts of that makes it out as laser light. In fact, that makes it the most powerful CW laser build
Aren't
I've
those
shown on this
lasers on the
channel.
order of milliwatts?
Now, in order to visualize this ridiculous power, I've stuck a mirror in there so you can see what the beam looks like. I've actually had to turn down the power here, because otherwise the beam just washes out my camera's sensor. Just to give you an idea on how ridiculous this oven is, the
Yeah, it's got
highest
the
danger
glasses.
rating a laser product can get is Class 4. That happens at half a watt of output power.
Yeah.
So if the output on this thing is 700 watts, that means that it eclipses that rating by over 1,000 times.
I think he needs his own category of laser safety setting.
That means you probably won't be seeing these in stores anytime soon. Alright, so the beam's flashy and all, but how good is it at cooking food? Let's start with a piece of toast. That smells so good. As you can tell,
That blue glow actually reminds me of the Cherenkov radiation you see in nuclear power plants. And you see that from when the neutrons effectively break the light barrier. That's the speed of light in water, and some fast neutrons, as well as other particles, can go faster than light, and that's what you see. That's not what's occurring here. Just the look reminded me of that.
this laser oven is really more of a laser grill since the cooking is one-sided.
Yeah, it looks like a waffle
Now, that's
iron.
not really that big of a deal since I can just flip it over halfway through. Well, that looks interesting. I wonder
Wow.
what that tastes like. Well, here goes nothing.
Oh, he's gonna.
Well, that's really good.
That is fascinating because it's like a combination of just white bread that you just see off the loaf in your pantry and then completely black. The fact that there's that much of a difference in cooked right next to each other is really, really cool.
Oh, it's like a carbon foam flavor. Really unique. I mean,
I like this
you can't
guy.
make toast like this in a regular
I
microwave.
really like this guy.
Popping popcorn with the laser is one of my most requested experiments to try on this channel. Let's see how well the laser oven can pull it off. That
looks
isn't
so
doing a very
cool.
good job. The beam must be too concentrated, since the surfaces of the kernels are vaporizing off faster than the inside can be heated to the point of popping. Let's see if I can fix that with a diffuser plate to spread out the beam. Okay, there it goes. Some turntable action couldn't hurt as well.
Nice.
Oh yeah, look at that. It's doing an awesome job now. That's way more interesting than the traditional way of cooking popcorn. Is laser popcorn as good as the microwave stuff? One way to find out. Wow, that is incredible. Jeez. Has like a smoky flavor to it. Yeah, it definitely beats microwave. Definitely beats microwave. Again, with those like hints of the carbon foam flavor, you know. That's one of my favorite flavors. It's funny because if I would have stuck with my PhD program, I would have been working on inertial confinement fusion lasers by now.
Hey, those are cool too. Yeah, and if you don't know what that is, inertial confinement, basically it's like you're taking a whole bunch of lasers and surrounding the fusion fuel for nuclear fusion. So something light using like helium-3, lithium-3, hydrogen, deuterium, tritium, other isotopes of hydrogen, something really small, and you focus a bunch of lasers to, like he says, confine it. That is one of the things you need for fusion is sufficient confinement time, and to just hold it in place really close together under extreme temperatures and under extreme pressures. So lasers is one method of doing that. It seems it's less popular than the magnetic field way of basically a tokamak style fusion reactor. So just another way to generate that sort of heat pressure and confinement time. But that's a cool gig, and I was It's funny that he mentions that because I was thinking about how he did the popcorn. If he was just going to surround it with a bunch of lasers, kind of like that, so you can cook the popcorn from all sides. That's really cool.
And yet here I am cooking popcorn with a laser oven. I guess I can do that as a YouTuber as well, since I actually have this set of optical amplifiers from a government attempt at building a laser fuser. And that's for a different video though. I've had campfire s'mores and I've had microwave s'mores, but I've never had laser s'mores. Perhaps the secret to the perfect s'more is by cooking it with laser beams. Oh yeah, check that out. It's making the chocolate nice and melty there. It looks like it's adding a bit of crisp to it as well. Yummy. Alright, let's add some marshmallows there. Huh, it's kind of hard to tell whether they're melting or if the white color is just reflecting off all the light. Okay, yeah, it's definitely melting there. Wow. Yeah, I think that's ready to eat. Man, I hope these things taste as good as they smell, because...
That's a cool idea, because usually they just get all
Alright, here we
burnt.
go. Wow. Yet again, I am very impressed. And one of the big themes about this laser oven I'm finding is that charred flavor, you know? Mmm.
That could be a good s'more.
Man, I love carbon. It's a shame that you can't just, like, sell these things at the store. Because, man, you guys are missing out. Now that I'm making campfire foods, I can't make s'mores without also giving hot dogs a try. One nice thing about the laser oven is that leaving the door open won't jam nearby electronics or make the FCC angry. However, my eyes would be destroyed in a fraction of a second if I took off my laser goggles. I probably should have spent more time designing a beam diffusing system, but whatever. That one's actually really good.
Like that he eats it.
Again with
so
that,
good.
it's like a char-boiled flavor, but I don't even need like a grill or whatever you use to do that. Yeah, there's this like really distinct aftertaste. I mean, it lasts a really long time. And I mean, really, a lot of things from this laser oven give an aftertaste that lasts a long time. How about a laser-cooked egg?
Ooh.
Is it even cooking in there? It's hard to tell since the wood's burning a lot, but it might just be reflecting off all that light.
Look at the shell.
I was kind of hoping for something like a hard-boiled egg here, but I don't know what's going on. Yeah, I don't think I'm going to be eating this one. Maybe I can do better with a different breakfast food.
Ooh, Pop-Tarts.
In all honesty, I'm usually too lazy to heat these things up and just eat them straight out of the wrapper. Fun fact, when I was a starving college student, I found that Pop-Tarts were the highest amount of energy I could buy for $1 in my school's vending machines.
Nice.
Breakfast of champions right here. It's a little on the crispy side. Yeah, it's alright. Not used to my, chocolate being so toasty, I guess. How about some double roasted cashews? I love the smell of roasted nuts. Wow, those give off a ton of smoke in there. It must be the oil or something. Well, here goes nothing. Oh. Oh, no. Oh. Oh, that's terrible.
I tried the s'more. I would try the s'mores.
That's one thing the laser oven can't do. Alright, I've had enough appetizers today. I think it's time for the main course. Many people will argue that nothing can beat the flavor of a microwave steak, but I think this laser oven can pull it off. Wow, I just can't get over that incredible smoky fragrance. I better flip it over to make sure it gets the other side. Yeah, that thing is being lasered to perfection.
It's gonna be well done,
I almost forgot. I can't have a steak dinner without some laser caramelized onions.
Just put it in there whole, don't even chop it. That's awesome.
The onion is a bit reflective to the blue laser light. I guess I can just leave it in there for a while. Okay, yeah, I think that's good enough for now. Wow, check out that beautiful meal. Now that is Instagram worthy. Let's give that old steak a try first.
I bet.
Alright, might be a little on the, might be a little overdone. It's kind of hard to tell, you know.
Yeah.
I'm not used to cooking with lasers. But, man, it is a delicious flavor. Again, with that, like, carbonization of the food there. Well, that was delicious.
Everybody guessed laser makes it smoky.
What should I try next? Probably the, caramelized onion there.
Just by itself? Okay.
Nice and sweet. You know, I didn't get any char in that piece. Let's try this piece. That is amazing. Wow. I almost forgot about my Texas toast. That's so good.
Expression on his face.
I love the future. Alright, I am stuffed now, now. So I figured this would be a good time to go over some of the pros and cons of my laser oven.
Here we go.
So the pros, right? I mean, the biggest one is it's a laser oven. I mean, cooking food with lasers is automatically cool. It also has a good way of like adding a smoky flavor to things. Sometimes that can be a problem. I mean, a lot of it has to come down with the oven likes to cook, like put most of its energy in like the first few millimeters of the surface of the food you're cooking. So that can be problematic. So that's why it like chars absolutely everything you put inside of it. I mean, if I were to use like red or IR lasers for this, like near IR, then it would have probably done a better job at cooking food more uniformly. Sure. And having a better diffuser plate in there would have probably helped too. But, I mean, this was just like, there could be improvements on it, obviously, but I feel like you could do a laser oven that would cook more uniformly and actually be, like, you know, comparable to a microwave. So maybe I'll make another oven with red lasers, or maybe I'll just make a mega microwave with a giant magnetron and do it that way. So yeah, it was an interesting experiment, and this was probably one of the most requested things to do in my channel, at least cook food with lasers. So yeah, I'm glad I did it.
I would have liked to have seen an inertial confinement microwave and just surround the food with lasers from all sides and just see what that does. But that was fascinating. Thank you so much for the recommendation of more of the styropyro laser fun stuff. This is another example of using nuclear technology peacefully. And hey, if you support using nuclear technology peacefully, please join me on my journey to a clean nuclear energy future by liking, subscribing, and commenting. Thank you very much for watching. I'll see you next time.